this problem. Okay, so we're going to solve this inequality. We're then going to graph it on the number line, and we're going to put it in interval notation. And I had a question about how to do the graphing of the number line on the Delta Math, so I'll mention how to go about doing that as well. Okay, so let's first talk about how we're going to solve this. I didn't see anybody put an answer on the chat, but let's work on it together then. So our first step, as we've done every equation so far, we follow the same steps for inequalities that we do for equations. We're going to remove the parentheses. So I'll bring down the 8. I'll distribute this -2. So -2 times 2x is -2x. Don't forget, you have to do the -2 times the 3. That's going to give you -6. Is greater than or equal to 4x minus 2. And then we look to combine our like terms, and the numbers 8 and -6 minus 6 are like terms. So I'm going to do 8 minus 6, which will give me 2. Just bring down this -2x greater than or equal to 4x minus 2. Now, as I've done all along, I want to get the variable to the left and the constant, the numbers to the right, especially when we're trying to solve an inequality. So I'm going to, even though it looks like simpler to do plus 2x, I don't want to end up with the x's on the right. If I'm not careful, I'm going to do my graph and my inequality is wrong. So I want to end up with the x on the left side. So I'm going to minus 4x from both sides, which will leave me the 2 that we had before. -2x combined with -4x gives us -6x, greater than or equal to -2. Don't forget those signs. And now I'm going to bring this 2 to the other side. So I'm going to do -2 from both sides, which will give me -6x greater than or equal to -4. And now I have to divide everything by -6. Now remember, when you're dividing by a negative number over here, you have to switch the sense of your inequality. Any time you multiply or divide an inequality by a negative number, the direction of the inequality changes. So therefore, the -6 divided by -6, I'm going over here, is going to give me x.
Clase.
Hello?
Estoy en clase.
Please mute yourself. Since we divided by -6, we're going to change this greater than or equal to a less than or equal to. And then I have to do this last thing, -4 divided by -6. Well, -4, a negative divided by a negative is positive. So that we're going to get a positive number, and I can reduce this 4/6, divide top and bottom by 2 and get 2/3. There, you can get fractional answers. You can have fractions in your equations or inequalities, or you can get them an answer with a fraction. This is the solution. X is less than or equal to 2/3. But we also wanted to graph it on the number line, and we wanted to put the solution on in interval notation. So let's first look at our number line. So here's 0, 1, 2, 3, and here's -1, -2. Now I have to locate 2/3. Now it doesn't have to be exact, but obviously 2/3 is between 0 and 1. So I'm going to put it right here. Here's my 2/3. And be careful. We want to be a filled in circle because it says less than or equal to. And we want our arrow, look at this is pointing to the left. So we need our arrow pointing to the left. That is what it would look like on the number line. If you were doing this solution on the number line in Delta Math, here's what you would do. You would go to the 2/3 and it would be printed out there. You wouldn't have trouble finding it. You'd click on the 2/3 and then hold down your cursor and drag it to the left. It will automatically make this a filled in circle. If you think it should be an open circle, then what you have to do is after you've made the arrow, go to the filled in circle and click on it, and it will change from a filled in circle to an open circle. Now, in this case, we want it to be a filled in circle, so you would leave it that way. In terms of interval notation, remember we always start our interval on the left and work our way to the right. What's all the way to the left is -infinity. Where's our point that's all the way at the right? It's the 2/3. Remember, with the infinity sign, whether it's on the positive or negative, you always use a regular parentheses. But when you have a filled in circle, when you have a less than or equal to or greater than or equal to, you have an additional equal to, meaning that the point is included, then you have to make a bracket. So this would be your answer in interval notation. Does anybody have any questions about that? Okay, great. So this is really a review of what we had done on Monday. Okay. And somebody's sending me a note that they got in a little bit late. I usually try to start each lesson with a review problem so that if you come in a little bit late, you're not missing new material. But on the other hand, if you weren't too sure about how to do things, that review is going to be really important for you. So try to be on time. I don't take attendance the first minute, but I will be taking attendance shortly. I do give people a little bit of an opportunity because I know there are sometimes you think you're going to get on and your computer doesn't connect right away. All right, so let's, do you want to do one more like this?
Yes, please.
Okay, let's try one more like this, and then we'll go further. Okay. So I'm going to erase this, and I'm going to give you another problem to try. Okay, we have 3 parentheses, 5x minus 6, less than 6 parentheses, 3x plus 5. Again, I'd like you to solve it as an inequality, then graph it on the number line, and also give your answer in interval notation. If you're going to give the answer on the chat, you could just, it's easy to type in the interval notation. And you just, where it comes to infinity, just write INF or something like that. See, because I don't know if you have the symbol, but otherwise you just put in the interval notation. Okay, so I'm going to give you a couple of minutes to try that. Okay, I'll give you one more minute. I see a couple of people that have come up with an answer. Both of you did not put it in interval notation. See if you could put it in interval notation. Okay, see a bunch of people have answered. Let's see. There. If we can do this together. Okay. So of course, the first thing, as usual, is to remove the parentheses. So I'll do 3 times 5x is 15x. 3 times -6 is -18. I leave it less than, and I do 6 times 3x, which is 18x, and 6 times 5 is 30. Okay, so to remove my parentheses, I've used my distributive property and I've removed the parentheses. Now we want it, and there are no like terms to be collected on either side. So now we want to start moving things. And remember, we want to get the x's on the left, the numbers on the right. So I have to get rid of this 18x over here. So I'm going to minus 18x from both sides. And 15 minus 18x will give me -3x. I'll bring down the minus 18, less than, this is out, 30. So now I have to get rid of this -18. I'll do plus 18 to both sides. So that'll give me -3x less than 48. And now I'm at my last step where I have to divide by the coefficient of the x, and the coefficient happens to be negative. Let's remember, when we divide by a negative number, we'll get x on the left. The less than will become a greater than, because anytime we divide by a negative number, the sense of our inequality switches. And 48 divided by -3 is -16. Now let's see. Did anybody come up with that answer? I see x greater, yes, I see quite a few of those. Don't forget, those of you who left it less than, that you have to change the direction of the inequality when you divide by a negative number. Yeah, so that's something to be, that's why I gave you this problem, because I want you to, it's the one thing that really makes it different than an equation. The one thing you have to be very aware of. Now, if we were, I also asked you to graph it on the number line and write it in interval notation. On the number line, here's my 0. My -16, I have to get to -16. So it's going to be pretty far out here. 1, 2, 3, 4, 5, 6, 7, 16 to the left. Let's say it's over here. You don't have to do a more exact number line than what I'm doing here. Since it says x is greater than -16, it means that the -16 is not included. It means this is going to be an open circle. And as you notice, this looks like it's pointing to the right, so our arrow is going to be pointing to the right. Again, if you were doing this on Delta Math, you would go to the -16, click on the -16, and then drag it to the right. It would turn out that this would be a filled-in circle. You would then have to, after you have the arrow there, go back and click on it to make it an open circle. In terms of interval notation, well, now remember, our intervals go from left to right. So the start of our interval is going to be -16. And it's going to go all the way to the right, which is till infinity. Remember, to the right is positive infinity. If you're coming from the left, you're starting at negative infinity. So we're going to positive infinity. Since -16 is not included, we make it a regular parentheses, and the infinities also always get regular parentheses. So it would be parentheses -16 infinity, close parentheses, as our interval notation.
Can you explain what again? Why is it an open circle? I didn't catch that one.
Okay, let me repeat that. Thank you for, the best thing you can do is ask me questions, because then I repeat. When there are two ways the inequality sign, you can have an inequality sign, let's say a greater sign, either just a plain sign like this, or sometimes it looks like this with this little extra line underneath it. This means greater than. In this case, this is telling me X is greater than -16. Any number bigger than -16 works in this inequality. But -16 itself does not work because it has to be greater than. That's why when I have just a plain greater than, I make it an open circle, because that is indicating that the -16 is not included. If I would have had a symbol like this, greater than or equal, this little extra line, that means if I had, let's say I have X greater than or equal to 1. What that's telling you is any number bigger than 1 or equal to 1, greater than or equal to. So 1 or bigger works. So that's where we do the filled in circle to indicate that that point is included. So when, keep it in mind, there's extra here, a little extra here, so you need a little extra here. You need a filled in when you have the extra line over here to show that it's included. Is that clear?
Yes. It's with both greater than or less than.
It would, yes.
Greater than or less than
So the
equal
less
to.
than symbol or the greater. In other words, there are 4 different symbols that you could have. You could have greater or greater than or equal to, or you could have less than or less than or equal to. And in both cases, this is the filled in one and this is the open one. This is the filled in one and this is the open one. The only difference between the less and the greater end is which direction the arrow goes. That clear?
Yes, I got it. Thank you so much.
Okay, great. Thanks. Thanks for answering the question. Okay, I think we're okay with this. So, I mean, again, I'll constantly review, and you'll see the homework on Delta Math includes a lot of these type of problems so that you can practice them. Want to talk about something else now that still has to do with inequalities. Everybody okay with my erasing this?
I'm sorry, I have to get off for like 10 minutes so that I can kind of get ready for work.
I'm sorry, I didn't hear. Can you speak a little? Didn't come out clearly. I couldn't hear.
I said that I have to get off for like 10 minutes so that I can get ready for work really quickly.
Your mic is very unclear. I'm sorry. Can you send me a chat?
I said that I have to get off for like 10 minutes so that I can get ready for work.
Oh, okay. Look, you have to do what you have to do. I know when they schedule these classes, they don't think about people living regular lives also. So you don't have to tell me that. I'm gonna take attendance. Let me take the attendance now, so at least they'll know that you were here. And then we'll go on to new material. And this is approximately the time I will take attendance, around half an hour into the course. Okay, so please listen, either say here or put on the chat that you're here so I know that you're here. Okay, Olivia, you mind if I call you by your first names? Olivia, are you here?
Yes, I'm here.
Okay, great. Isis. Hi, I see. You're ahead of the game, Isis. Thank you. Alvaro Blake. Lewis Hart Cariola. Kayola. Hi, great. Were you here on Monday? Because I don't have you marked. Okay, great. What you can do if you miss a class is you can watch the YouTube video that's posted on Blackboard for that class. And if you do, you can send me an email note that you watched the class, and then I'll take off the absence. Emma Charlton, Emma. Demetrius. Desmond Fleming. Desmond.
I didn't hear you. Did you call Shania Haley?
I'm sorry. Who is speaking?
Shania. I didn't know. I didn't hear you call me already.
You're my next person. Were you, Shania, were you here on Monday?
Say that again.
Were you here on Monday? Were you here this past Monday?
I don't know. It's breaking up. Let me. Yes, Monday. Yes.
Okay, so I'm checking my.
Okay, thank you.
Caden Ricardo Harris. You here? Kayla Harris. Kayla. Sanjita Hussein. Okay, let's see, you're here. Okay. Sometimes it takes a while until the chat works. Oriana Jonas. We were speaking before.
Yes, I'm here.
Yeah, thanks. Tahira Joseph. Tahira. Okay, good. I see you here. Michaela Martinez.
I'm here.
Yeah, hi, good morning.
Good morning.
Were you here the first Friday?
No, I wasn't here. I was here on Monday, though.
Okay, yeah, I have you for Monday, but I don't have you for Friday. Okay. Kiana Perez.
Here.
Good. I also didn't have you that first Friday, is that correct?
Yes.
Okay, great. Carly. Okay, thanks. I see you're here. Tatiana Sanchez. Oh, okay, so you're here. Jenna Pierre.
Here.
Yeah, hi. So good. Naya Sims. I know you're here, Naya, because I saw you before. Kazandu Small.
I'm here.
Okay, great. Were you here on Monday?
On Monday?
Yeah,
Yeah, I was here for the first class.
no, this is the second class was
Yeah,
Monday.
for the first yeah.
Okay, so I have you. I didn't get you, so I'm changing that. Okay.
All right, no problem.
Trainer Small, Trainer Joy Small. Jean Thomas. Okay, I got you. Okay, Jean, is Jean here? Okay. Okay. I do take attendance each session. Part of my requirements for this course is to take attendance. Again, as I mentioned before, if you miss a class, you can always make it up by going to class recordings in our Blackboard account, and you'll see each class, each recording is there as a YouTube. And if you follow it and you do it, and I can tell if somebody's watched it or not, and you send me an email that you watched it, then I will count you as present for that class. Okay. Sanjita, I see that you came on. Okay, great. I think I have everybody now.
Thank you, Professor.
Am I saying your name right?
Yeah, it's Sanjita.
Okay. Okay, so let's talk about something new. What if I got something that looks like this? This is something you'll never see in an equation, but occasionally when you have an inequality, we have something that's called a double inequality. I'm going to read it. -6 is less than x is less than or equal to 2. This is sometimes the term is called a compound inequality. You know, when you have a compound statement, I went to the store and I picked up milk. You're saying two things. A compound inequality is the same idea. You're saying two things in basically one sentence. What we're saying is that -6 is less than x. That's one inequality. And also at the same time, the x is less than or equal to 2. Now, really, we usually don't say -6 is less than x. Usually, when we have an inequality, we want the x to be on the left and the number to be on the right. But in order to use this compound inequality, we have to put it so that the number is on the left and then x is on the right. Well, just remember, if -6 is less than x, that's equivalent to saying that x is greater than -6. you can always turn around an inequality. As a matter of fact, if you solve an inequality and you get the X on the wrong side, the X is on the right instead of on the left, you can switch it by just switching every single thing. Put the number on the right, the variable on the left, and of course then the inequality gets switched around, because saying -6 is less than X is equivalent to saying that the X is greater than -6. So basically what this compound or double inequality is saying is that we have an X that's greater than -6, and at the same time, it's less than or equal to 2. Now, what does that really mean? Obviously, this is a much quicker way to write it. What does that mean? Well, let's look at our number line. I'm going to put both of these numbers on the number line. Here's my -6, and here's my 2. To say X is greater than -6 means then I'll have an open circle at -6 because it's greater and not greater than or equal to, and an arrow that's going all the way to the right to infinity. To say that X is less than or equal to 2 means that you had an open, a filled-in circle at 2, and now your arrow is pointing to the left. Now, you have both of these things going on at the same time. Now, you know when you say and means it's happening simultaneously. It's exactly at the same time. I went to the store and I bought milk. I'd have to do 2 things for that statement to be true. I'd have to walk to my store or go somehow to the store, and then I'd have to also buy the milk. If I just went to the store and I bought Coke, that statement wouldn't be true. If I went to the gas station and I bought milk, that statement wouldn't be true either. Both parts of those statement has to be true when we have an and statement. And that's also true when we have this double inequality in this situation where we're using a inequality twice. It means that both of those statements have to be true at the same time. In other words, we have to look, where do these lines cross? Where do they intersect? And it's right in between here. In other words, really, the correct way of graphing this would be, here's my -6, here's my 2, an open circle at -6, and a closed circle at 2, and a line joining them. But we can't have anything to the right of 2 because that wouldn't fit in with X being less than or equal to 2. And we can't have anything to the left of -6 because that wouldn't fit in with this. In order for this double inequality, this compound inequality to be true, we're talking about on our number line, points between starting at -6 and ending at 2. Now notice, I gave you this whole long explanation, but if you think about it, this almost mimics, let me erase this so I can show you. This almost mimics the number line. That's why we use this. We put, you always put in your 0, put in the number that's on the left and the number that's on the right. If it's a less than, make an open circle. If it's a less than or equal to, make a closed circle. So this one's going to be an open circle, and this is going to be a closed circle, and just detach it. Notice my whole long explanation was difficult, but if you look at it, this is what this means. The inequality and the number line coincide. And if you think about it also, it just means that what you're talking about, your x's are the numbers that are between the -6 and the 2, where the -6 is not included, but the 2 is. In terms of interval notation, it's also easy to write this in interval notation. You start with, just like we've always done. Our number on the right is the negative, on the left, I'm sorry. We start with the number on the left, we go to the number on the right. So our first number is going to be the -6. Our ending number is going to be the 2. At the -6 side, we're going to make a regular parentheses because it's an open circle. But at the 2, we're going to make a bracket. Notice all 3 of these things are telling us the same thing. -6 less than x less than equal to 2. The number line is an open circle at -6, a closed circle at 2, and a line in between. In interval notation, it's parentheses, -6, comma, 2 brackets. So that's, there are other types of compound inequalities that use the term or rather than and, but we're only going to talk about this type, this double inequality, which even though we don't see the word and, indicates that it's and. 2 things are going on at the same time. Now, I'm going to do one more problem and then I'm going to give you one to try. So let's try one more. Suppose I gave you something that looks like this. Suppose I wrote this, -40 is less than or equal to 20x plus 20, which is less than 20. What if I gave you this double inequality? And I ask you to solve it. Again, when we're going to solve it, we're going to write it on the number line and an interval notation. This is a little bit more complex than what I did before, simply because I don't have just an x in the middle. I have a whole algebraic expression in the middle. And I can't start drawing this on the number line or solving it until I get the x alone in the middle. In other words, my object is to end up with just an x in the middle and 2 numbers, one on the right, one on the left. the inequality signs always have to be in less than or equal to, because you're always working with the smaller number on the left and the larger number on the line, right? So that we're doing things according to the number line, and the number line, always the smaller numbers are on the left, the larger numbers are on the right. And that's why when we do this double inequalities, we're only using less than or equal to symbols. We don't use the greater symbols. Okay, but again, we always concentrate on trying to get X alone in the middle. So the first thing I want to do is get rid of this regular 20. So I'm going to subtract 20 from the middle here. Remember, I always focus on the middle. Now, here's what we're doing. We're actually working two problems at the same time. Whatever we do in the middle, we have to do the same thing at both ends. So since I'm doing minus 20 here, I'm going to have to do minus 20 on the left side and also minus 20 on the right side. I'm actually being very efficient and doing two problems at once. Okay, now I just follow through. Negative 40 and negative 20 gives me negative 60. This stays less than or equal to. This 20 drops out, so I'm left with 20x. And here I have less than, and 20 minus 20 is 0. So I'm further along because the middle is getting simpler. The only thing I still have to do is I want to get, instead of 20x, I want to get x. Now remember, the 20 is a coefficient. So what we're going to do is divide by it. Remember, you never subtract by a number that's directly in front of a number. You divide by it. So we're going to divide this by 20. Now, whatever we do in the middle, we have to do at either end. And again, since we're dividing by a positive number, we're leaving the direction of the inequalities the same. If this would have been a negative number, we would have had to switch the directions of both inequalities, but now these are the same. So let's finish this up. Negative 60 divided by 20 is negative 3. This stays less than or equal to. This becomes just x. And this stays less than. 0 divided by 20 is 0. So we end up with, this is our solution. Our solution is a double inequality, a compound inequality. Again, if we wanted to do it on the number line, we go to the negative 3 and the 0. Here are the number on the left is negative 3, the number on the right is 0. This is less than or equal to, so it's filled in. This is just equal to, just less than, so it's open. And then we join. By the way, if you were doing this on Delta Math, what you would do is you would click on negative 3, drag it until you got to 0 and click there so that it would stop, because you don't want it going on all the way. And then again, if this would be a filled in circle, if it's already filled in, fine. If this is filled in, then you click on it and you opens it up. In terms of interval notation, your number on your left is negative 3. Your number on your right is 0. At the negative 3, we need a bracket because it's filled in. But at the 0, we need a parenthesis. So here are the 3 ways to write the solution of that double inequality, that compound inequality. Any question about this? Do you think you're ready to try one on your own? I'm going to, can I erase this? Okay. Okay. It reads -3 less than or 2x plus 5 less than or equal to 7. Again, we have a double inequality, a compound inequality. Please solve this, draw it on the number line, and write it in integral notation. I'll give you a few minutes to try that. Yes, this is a 7. That looks good. Jean. Okay, I think we can start working on this together. I see a few people didn't put the answers on the chat. Let's see if we come up with the same answers. Again, we see this double inequality, this compound inequality, so we want to get the x alone in the middle. And remember, whatever we do in the middle, we have to do it at both ends. So the first thing I want to do is get rid of this 5. So I'm going to minus 5 in the middle, which means I'm going to do minus 5 on the left and also minus 5 on the right. I'm actually doing 2 problems at once. Okay, so I'm doing -3 and -5 together. They combine to -8. This stays a less than. The 5s are gone, so I just left with a 2x. And this stays a less than or equal to, and 7 minus 5 is 2. Don't forget to do both sides of the inequality. Again, in our middle, we have a 2. We want to be left with just a plain x. So I'm going to divide the middle by 2, which means I'm going to divide either end by 2. So we have -8 divided by 2 is -4. And this stays less than because we divide by a positive number. This stays x. And this is less than or equal to 2 divided by 2 is 1. Here is my solution as an inequality. In number line form, here's my -4 and my 1. At the -4, I have an open circle because it's just less than. At the 1, I have a filled in circle because it's less than or equal to. And I have a line connecting the 2 points. The interval goes from -4 until 1. It starts at any number between -4 and 1 will work in this compound inequality. But if I take a number that's bigger than 1 or a number that's less than -4, it's not going to work. So it's only these numbers in interval notation. -4 is the start of our interval. 1 is the end of our interval. This is a parentheses because it's an open circle. This is a bracket because it's a closed circle. So this is really probably the easiest way to write your answer if you're trying to type it on your computer, because you don't need any special symbols. You can just use the regular keyboard. You don't have to make pictures or anything of that nature, or less than or equal to. So, and I think a few people did get that answer. Does anybody have a question about that? Okay. That being the case, I want to do one more topic today. And let me just mention, since we aren't going to be having class until next Wednesday, we have both Friday and Monday off. I'll answer you in a second. So therefore, make sure to look for any homework on Delta Math. There'll be some examples. There might be even two homeworks. Always look at the due date of the homework, because the due date tells you when we're going to review that topic in class. If you cannot do the homework on Delta Math on time, then you can always do it later. You will get almost complete credit. You get 90% of your credit if you do it during any time this semester. Obviously, it makes more sense to do it when it's assigned, but if you get a little behind, don't just stop doing it. Make sure you do your homework, because a significant part of your mark comes from whether you've done the homework on Delta Math or not. You have to do at least, if there are 20 homeworks, which is usually about what there are 20 or 25 homeworks over the term, if you do 18 out of 20, then you'll probably get full credit. I'll tell you later on in the term exactly what your homework mark is, but it is included in your final grade. Don't put off doing the Delta Math. Okay, now, Michaela, to answer your question, yes, you must have both numbers. This is an interval. You can't just have x greater than -4, or -4 less than x. Then it's not taking into consideration this 2 divided by 2 is 1. In a double inequality, you have to have two separate numbers, a starting number, which in this case was a -4, and an ending number of 1. It's not enough just to do one side of the inequality. You have to do the whole inequality. To do whatever you do at one end, you have to do at the other end and include both answers. Is that clear? Okay, great. All right, so now let's talk about another topic. And that topic has to do with something that's called absolute value. I'm sure you've all seen this before. You see a symbol that consists of two straight lines, one on either side of a number, and you'll see something like this. Some number in between. That's read the absolute value of -5. Now, what does the absolute value of -5 mean? The absolute value of a number is what is the value of the number, not including its sign. If we understand the purpose of the sign of a number, we'll understand why we sometimes want to talk about absolute value. If you look at your number line, if you look at both the -5 and the 5, for example, the 5 is 5 paces or 5 steps to the right of the origin. The -5 is the same 5 steps, only going in the opposite direction. It's going to the left. The purpose of the negative sign is to indicate a direction. And you know what? You've probably seen it in terms of, let's say, the temperature outside was -20 degrees. What is that negative indicating? The 20 is telling you how many degrees it is. The negative is saying it's below 0. Or you might see you have -$15 in your account, and you're not going to be very happy about that because the 15 is telling you how much, but the negative is telling you it's below 0. It means that you owe $15. So the purpose of a negative sign in general is to indicate a direction. And for example, somebody might be traveling and we decide that east is positive and west is negative. So if I tell you he went positive 20 miles, you'd know he went 20 miles to the east. But if I told you he went -20 miles, you'd know he went 20 miles to the west. So again, we can, in real life, the point of that negative sign is to indicate a direction. On our number line, it indicates right or left, but depending on what the type of object is, it's just indicating 2 different directions. Now, what's the point of the absolute value? Suppose I asked you, how far is -5, the point -5 from the origin? Now, when I'm asking you how far something is, I just want to know the number. I'm not interested in the direction. I'm just asking you how far it was. So therefore, I just want to know how far is it. If I were going to start here, how many steps would I have to take to get here? And obviously the answer is 5. So that's the point of an absolute value. It's to indicate the value of the number without indicating its direction, just the actual value. And it's very easy to find the absolute value of a number because all you have to do is drop its sign. In other words, the absolute value of -5 is 5. The absolute value of 150 is 150. Remember, you're not changing the sign, you're dropping the sign. So your absolute value is always going to be a positive number. And I think everybody knows this, that if you want to find the absolute value of a number, just drop its sign and you'll be okay. If it has a negative sign, it'll become positive. If it has a positive sign, it'll stay positive. If it doesn't have any sign, that means it's positive. So therefore, the absolute value of a negative number is positive. The absolute value of a positive number is also positive. Now we want to talk about how do we solve equations that have absolute values in them. So let's start with a relatively simple equation. Suppose I gave you this absolute value of x is equal to 3. If you want, I see you're talking about the Delta math code. There are two places where you can find it. I mailed it out, I emailed everybody on Monday the code. So if you check your emails, you should find it there. If not, go onto your Blackboard account and the information page, it tells you exactly what to do to get onto Delta math. Okay, so let's go back to this. We have the absolute value of x is equal to 3. What does that say? I have this variable, I don't know what it means. I have an unknown number. I don't know what it is. All I know is after I take its absolute value, which means after I drop its sign, I'm left with 3. Well, there could be two possibilities. Either the x could be equal to 3, or it could have started out being negative 3. If I take the absolute value of 3, it gives me 3. Because the absolute value of any positive number is that number. But if I started out with negative 3 and I took its absolute value, its answer would also be negative. Its answer would also be 3. So there actually are two solutions to this absolute value equation, the positive 3 or the negative 3. You could have interpreted it on the graph as well. To say that the absolute value of x is 3 means that you have to go 3 spaces to get to x. Now you could go from the origin 3 to the right and you get to regular 3. But you could also have gone 3 spaces to the left and gotten to negative 3. So again, your answer is either 3 or negative 3. So what do we see? Number one, when I give you an absolute value equation, you're going to end up with 2. This is our first situation where we're dealing with what we're getting is 2 answers. We're getting 2 answers because either the positive or the negative number would work in this case. Okay. What if I had given you this? Suppose it gave you that the absolute value of x is equal to negative 1. What should my answer for x be? A lot of people would say, well, it should be 2 answers, 5 and negative 5. Not right. Because I just put a false statement on the board. The absolute value always has to be positive. Remember, when I take the absolute value of a number, I'm dropping its sign. It's impossible for an absolute value to be equal to a negative number. So, whenever you have an absolute value, you're going to equaling a negative number, you're going to write no solution. Or alternatively, this symbol for no solution, which is the 0 with a line through it. Right? That it means no solution as well. It is impossible for the absolute value to be equal to a negative number. Okay. So these are how we solve very simple absolute value. We take our number. You can't leave the absolute value sign. You take what's inside the absolute value and you break it up into 2 numbers, one being the positive and one being the negative. Make sure that if you start off with the absolute value being a negative number, that you don't even try that problem, that right away you write no solution. Okay, so let me show you how to solve an example that's a little bit more complex than just X. We're gonna depend on what we just said now. Suppose I gave you the absolute value of 2x minus 3 equals 5. And I ask you to solve this equation. So the first step would be, if you have something outside the absolute value, you have to get the absolute value all by itself. So it has to be all by itself on one side, the numbers on the other side. If it's not, make sure you get it that way. We already have it isolated. Then, once you have your absolute value by itself, look at the number on the other side. If it's positive, you're going to go further. If it's negative, you're going to stop right there because it's no solution. The absolute value can never be equal to a negative number, because that's not what the definition of an absolute value means. Okay. We decided that we can go further with this. So what do? Exactly what we did before. We take what's inside the absolute value and break it up into two equations. We do 2x minus 3 equals 5, the regular equation you'd expect. But you also have to do 2x minus 3 equaling negative 5. It has to be two separate equations, one equaling the positive number, one equaling the negative number. And you solve both of these equations. These are not hard equations to solve. Here I'm going to do plus 3 to both sides, which will give me 2x equals 8. And I'm going to divide by 2. So that'll give me x equal to 4. One solution to this problem is x equaling 4. But I'm not finished. I have to solve the other equation. Again, I add 3 to both sides. And I get 2x equals, well, negative 5 plus 3 is negative 2. And again, divide by 2, and I get x equal to negative 1. Now notice, my answers can be negative. What can't be negative is the absolute value. And you're supposed to get two answers to your absolute value equation. If you want, you can check. I'm just going to check. I usually will not check, but I'm just going to show you how the check works. First, checking with x equal to 4. Go to your original equation and replace the x by 4. So I'll get 2 times 4 minus 3. The absolute value of that equals 5. Well, 2 times 4 is 8 minus 3 equals 5. And the absolute value of 5 does equal 5. That's a true statement. So this checks. What about negative 1? Let's do the same thing with negative 1. We're going to do 2 times negative 1 minus 3 equals, absolute value equals 5. Now 2 times negative 1 is negative 2. And negative 2 minus 3 is negative 5. So this, I'm going to get the absolute value of negative 5 equaling 5. And guess what? The absolute value of negative 5 is negative 5. That also checks. Both answers work, and you must give both answers. If you only give one answer, you're going to be marked wrong, because an absolute value equation needs both answers. Let's do one problem. I'm gonna give you a few minutes to try it on your own. And then, I'm gonna say, have a good week. Let's do one more problem. A hint. There's something outside this absolute value. The first thing you're going to have to do is to get rid of it. You must first isolate your absolute value. Get the absolute value, doesn't matter what's inside it, that you can leave alone. Just make sure that there's just the absolute value on one side of the equation and no other numbers or letters. Okay, I'm giving you a couple of minutes to try this. Okay, let's do this together because we're getting close to the end of our class. Remember what I told you. You want to get the absolute value alone. And I have a 3 on the other side, outside this absolute value. So I want to get this 3 to the other side of the equation. So to start out, I'm going to have the absolute value of 2x minus 5 equaling 1 minus, canceled out, 1 minus 3, which is -2. First step, get your absolute value by itself. Now look at that number. Is it positive or is it negative? It's obviously negative. If it's negative, remember what I told you to, it means you can't go any further. There is no solution to this problem. So in this case, there was very little work to do. But notice, I didn't notice right away that it, because when I started out, this was a positive number, but I have to judge it after I have the absolute value by itself. Okay, does anybody have any questions they want to ask before I dismiss class? Okay, then have a nice weekend. I'll see you next Wednesday. It's a whole week until I'm going to see you again. And work on getting, if you haven't done the Delta math yet, work on that. And again, if you have any questions, you can always send me an email. In terms of the type of, there's not one specific calculator that I'm requiring you to have. What I want you to have is a 2-line scientific calculator. And if you have any questions about whether your calculator is the correct calculator, just send me a picture by email and I'll let you know. Okay, have a good day.